Today we're doing P5 Day 2 of factoring, and our learning goal is for you to be able to factor difference of squares, sum and difference of cubes, and factoring algebraic expressions that have fractional and negative exponents. So we're going to start with factoring difference of squares. And when you do these, you need to make sure you know your perfect squares. And with factoring of this sort, both of your terms will be perfect squares. Now I'll just do a couple. And so all you have to do is square root the first term and square root the second term. And since they said difference of squares, one is positive, one is negative. So we need to make an x squared, so it'll be x and x. And then a 4, square root of 4 is 2, so one is positive, one is negative. And then you're done. And then same thing with here. If you square root 81x squared, you get 9x and 9x. And one's positive, one's negative. Square root of 49 is 7. And then you're done. Now sometimes you may have a repeated perfect square. Like this. So when you have an x to the 4th, you need an x squared and an x squared. And you need a positive and a negative again. The square root of 81 is 9. The difference, the minus one, can be broken down again. The one that's plus cannot, because that's not a difference of squares. So x squared minus 9 is also a perfect square. So we need x and x. And then we need a plus 3 and a minus 3 to make 9. So that's what happens when you have a repeated factorization. And the only one that can go down further is the one that has minus. There's also called a perfect square trinomial when there are 3 terms. And what that means is when you factor it out, they're going to be perfect squares again. So you're going to square root x squared, which would be x and x. And you would square root 9, which is 3. And they have to both be positive. And so when you write it out, it'll be x plus 3 squared. The 6 comes in because 3 plus 3 is 6. So if you double 3, you get 6, but if you square 3, you get 9. Now over here, you'll still square root 25x squared, which would be 5x and 5x. And then you'll square root 36, which would be 6 and 6. And they both have to be minus. So you'll write it as 5x minus 6 squared. The 60 comes in because if you do negative 30 and negative 30, that's negative 60. So if you double it, you get negative 60 on the inside. And then the last 2 terms is 36. So that's how that works out. When factoring sum and difference of cubes, you're going to see something like this. And what you're going to do first is find out what cube gave us, or what term cube gave us x cubed, which is x, and what number cube gave us 8, which is 2. Okay? So you're like cube rooting. This part, you cube root the 2 terms. Okay? And then over here, we're going to use the acronym SOAP. SOAP. And that's going to help you figure out, well, actually, it's SOPS, which is SOPs. So what you do is you square the first term, which is x squared. O means opposite sign, so instead of plus, we're going to use minus. P means product, so you're going to multiply x times 2 and get 2x. And the last s, you're going to square the 2, which will give you 4. And so that's how you factor a cube. So let's try another one. So remember, the first thing you do is cube root the first 2 terms. So the cube root of 64x cubed is 4x minus the cube root of 125 is 5. And then we use SOPs. You square the first term, which will be 16x squared. Opposite sign would be plus, because that's opposite of minus. Product means you multiply those 2 together and you get 20x. And the last s is you square the negative 5 and you get positive 25. And that's how you factor a cube. This is just reviewing over factoring. The first thing that you always want to do is look for a GCF, which in this case would be 2x. And then you write out what's left. And then you always check to see if you can go further, which in this case we can. So we need an x and an x, which makes x squared. And 2 factors of 4 to add to give you 4 would have to be 2 and 2. You can write it like this, or you can write it like this. So always look for a GCF. Determine how many factors there are, because that'll show you how to factor. If it's 3 terms, you could factor the trinomial. It may be a perfect square trinomial. If it's 2 terms, it'll either be a GCF or a perfect cube, so you always have to look at what you have left. Okay, let's try another one. Okay. I'm going to rewrite this so that my x terms are together. Because if you notice, I have this a that's by itself. So I'm going to factor this first to x plus 4 times x plus 4. And then I'm going to rewrite it so it looks like this. Okay, now I have 2 perfect squares. So I have x plus 4 plus 5a and x plus 4 minus 5a. And that's how you factor it. Okay, our last type of factoring is when your terms have negative and fractional exponents. This is probably the most difficult concept to grasp, but I'm going to try to make it painless. Okay, so here you still want to pull out a GCF, and the common term, as you can see, is x plus 1. But our job is to figure out what's the most we can take out. This one has a negative 3/4, and this one has a positive 1/4. That means that the most that we can take out is a negative 3/4 because it is the smallest one. So if you take out a negative 3/4, then you're left with x in the first one plus x plus 1 to the, so just imagine if you had 1/4 and you take away 3/4, so you're doing 1/4 minus negative 3/4, which would give you, that means you'll be left with 4/4, which equals 1 whole. Okay? So from here, we always have to simplify this because you know we can't have a negative exponent. So I'm just going to simplify this because since we're adding, x plus x is 2x plus 1. And this has a negative exponent, so it goes on the bottom. And then you're done. All right, let's try another one. Okay. They both have an x minus 1 in common. We know that. We just have to figure out how many we can take. Since that's the smallest one, that's how many we'll take out. And then we'll be left with x in the first one. And over here, we're left with x minus 1 to the, so we had 1/2. And we're going to take out a negative 1/2. So that'll leave us with 2/2, which equals 1 whole. So I'm going to do like the other problem and simplify that. To 2x minus 1. So to rewrite that, you'll get 2x minus 1 on the top because it has a positive exponent. And x minus 1 to the 1/2, which had a negative exponent, goes on the bottom. So you always remember to take out the smallest power that you possibly can, because the other one won't have enough. If you took out the largest, it won't have enough to factor out. And then that's it.